Hi, everyone. This is Team VGAI. Team members,
My name is Nathan Jonas.
I'm Spencer Cruz,
And I am Craig Gorney.
and our project advisor was Ali Manai.
All right, we'll start with project goals. So our first goal is to create a video game where gameplay is enhanced by decisions made through artificial intelligence. This will create entertaining gameplay. Our plan was to create a small-scale, single-player, first-person shooter game where the in-game enemy learns to defeat the player. Our second goal is to utilize the MindMaker library to implement reinforcement learning artificial intelligence within our project. There are in-game assets that track data for these RL algorithms. Data is in the form of observations, actions, and rewards. The reinforcement learning algorithms are fed observations to create actions, and the action creates rewards based on its success against the player. Rewards are then used to train towards or against the selected action, and this process will create an intelligent system. While the game persists or the user continues through the rounds, the enemy will continue using reinforcement learning to learn how to defeat the player. And finally, our third goal is to create a fun and modular gameplay where the engagement is generated from the game systems and not its content. Intellectual merits. Our first one is reinforcement learning within a video game. So this video game focuses on enhancing gameplay with reinforcement learning, so the enemy continues to gain intelligence as the game goes on. Reinforcement learning, one of the basic machine learning paradigms, enhances our video game in a unique way, unlike others. This is not common in many modern day video games, and we hope to promote this unique gameplay experience. Secondly, utilization of Unreal Engine's various amazing libraries. The game map has been co-designed by Spencer, Craig, and I for a realistic, intense game experience. We have created a spooky abandoned building located in the valley of large mountains, and most of these components used to build this map were made with Unreal Engine's free or low-price libraries. This allows for fast, easy design of a custom game map. Third, additional game logic creates an enhanced user experience. Both the player and AI enemy have a functional health system, ranged weapon, and three-dimensional movement. The game menus have been created to direct the user within the game. These additional enhancements provide a more superior user experience. Finally, multiple reinforcement learning algorithms in a single video game. Reinforcement learning has been created for offensive movement and/or weapon aim and fire. The observation space for both learning algorithms has been simplified to increase the training rate. Some of the broader impacts of our project. Artificial intelligence and reinforcement learning are both growing fields in today's world. They both impact our everyday lives. Companies are using AI to enhance workplaces, provide personalized recommendations, and replicate human behavior. We are attempting to bring AI into the video game world. Companies spend millions of dollars on video game content, and this could be lowered using AI to make decisions for them. It could also improve the quality of gameplay in the long term, as it would avoid monotony in gameplay without manually changing how the game functions. By considering our game to be an environment for training autonomous machine learning agents, we can collect data and real-time update the learning agent to behave in a structured manner. This game development strategy will be widely used and hopefully continue to grow in complexity in the future.
Moving on to design specifications. Our project is written in a combination of both C++ and Unreal Engine blueprints. The C++ is used mostly for the default Unreal Engine properties, so our project is using it mostly for the physics engine. The rest of the code is written in Unreal Engine blueprints, which is basically a proprietary language which controls the artificial intelligence and game flow. The design of our game is simple. As a video game, our end goal is to create entertaining experience through modifications to the enemy AI behavior. So you can see here, this is our basic idea. We have the user and they're playing the game and the AI is training. And then the game becomes better due to the AI training, which creates a fun and entertaining gameplay loop. Moving on to how the game actually works, we created a demo game called The House in the Hill. And after you start the game from the main menu, we're going to spawn a new enemy with a reinforcement learning algorithm, which is either going to be the combat moving or the aiming and fire. So then after you spawn the enemy, the player and AI are going to fight, which means that they're going to run around the map. They're going to try to find each other based on sight and sound. And then they're going to get into situations where they're in a shootout. So depending on the gameplay actions, we're storing those and using them to train either the combat movement or aiming and fire using MindMaker's PPO2 training. So dependent on the action, the AI will either be rewarded or punished. So if the action was successful, it will gain a reward. If it's punished or unsuccessful, it will lose a reward or gain nothing. So during the game, the AI's choices are being evaluated and improved. And so once the fight ends, there's a small downtime. We'll spawn a new enemy, and this loop will continue until the player dies. All the while, the AI gets smarter and smarter at predicting the player's movement choices and firing options. So here's our basic reinforcement learning design, going over the observations, actions, and rewards for each of the reinforcement learning algorithms. So for our aim and fire, we are observing the player dodge pattern by marking how the shot missed, left or right. And then we're going to choose an appropriate shot angle from the predetermined choices. So based on their left-right choices the player has made in their movement, we'll be able to determine where we will need to place the bullet to hit them next. And after firing, we're going to receive a reward based on how close the shot was to hitting the player, where the full reward is actually hitting the player, a half reward is barely missing the player, and no reward is missing wide. For the combat movement, we are observing the distance to the player character and the distance to the nearest cover point. And then we're going to choose an appropriate action between strafing, which is kind of moving back and forth, left and right, kind of some confusing behavior. We're going to approach the player, or we're going to take cover. And then after moving, we're going to receive a reward based on whether or not we're at an appropriate firing distance to the player, we'll be able to hit them easily, and being close to cover.
All right, so the technologies we used to achieve our end goal, the first one we used was Unreal Engine 4, which is a free 3D game engine that is very accessible to both new and experienced users. It's used for the physics, the lighting, the collisions that we use, and all the movement that we use. It's also the front end of how we use the AI and translated its movements to interact with the user. In the more of the back end, we used MindMaker, which is what we use to control the AI and how we fueled its reinforcement learning. MindMaker more specifically is a Python web server that we can plug into Unreal Engine 4 to act as the environment for machine learning. And it's pretty simple. It just links into the engine through a socket. And those are the two main technologies we used for our game. For our first milestone, the biggest thing we wanted to do was determine where we were going in the first place. So we kind of had an idea that we wanted to do a video game that implemented some smart technologies. But outside of that, at this time in the project, we weren't very familiar or close to coming up with a really cut in stone image. And then when we kind of got the idea of where we were going, first thing we needed to have everyone do is get Unreal working on their devices. Once we got that down, we started working on the movement inside the engine itself from the player to the AI. So that's when we created the opponent that could move as well as the player that could move, and we had a map that they could move around in. The fourth milestone was getting MindMaker plugged in and working to work with that opponent that we created. And then for the 5th milestone was when we actually started writing our own reinforcement learning algorithms that we could make work with MindMaker to actually fuel the AI. And then the final and last milestone is when it all came together, when we had the full map, the user interface, the menus, and all the small things that make it work behind the scenes. For the results, what we have done so far, we have the complete map with built lighting and everything. Everything is textured. Everything that needs a hitbox has a hitbox, so you can interact with it. You can run through it. You can run into walls like you're supposed to. You can go up and down steps, you can fire, and you can, look at all the pretty things that it has to offer. And then we had the systems in place for firing, making decisions, moving around, and having the AI, interact with the environment itself. And then after that, we finished the health system. So we implemented how to keep track of the round you're on, the weapon charge so that you're not just spam firing or the AI is spam firing, and then the health bars as well, which is the most basic component of a first-person shooter. And then we got the reinforcement learning for the AI to aim well, which Spencer talked about that earlier. And then we've also completed the reinforcement learning algorithm for movement, making smart movements. To be done, the first thing, and the two algorithms can't actually coincide with one another due to how the MindMaker plugins work. So something that we look forward to doing is when the MindMaker plugin is updated, we can actually have those run synchronously with one another. And then there would be a third algorithm that we can throw in there, which would improve its movements outside of non-combat situations. And then the last thing would be small bug fixes. Challenges, the first one was time, because we kind of came up with this decision in early of fall semester, and none of us really knew where we were headed from that point other than we had the goal in mind. And then the next one was scope, because as mentioned earlier, making a really nice looking game requires a lot of work. So the biggest challenge was how to divide up that work, because all of us had to learn Unreal from scratch, MindMaker from scratch, as well as how to do the modeling inside Unreal to make things look good in the first place. And then the last one kind of ties in with what I mentioned in scope, the professional and technical experience. The biggest challenge, I think, was learning how all of this works together, because we kind of hit a bump in a road when we started tackling getting MindMaker to work inside Unreal. That was probably our biggest challenge, is after learning all of this from scratch and then getting it to work together as well. Luckily, we overcame all of that to produce an amazing game. That is the end of our presentation. The link and the files for the game will be in our poster. So if you do download and play the game, good luck to all of you.